Hello everyone, my name is Anthony Shivkumar, and in today's video I just wanted to do a recap of assembling the Prusa MK3 printer. And yeah, it took me around, I would say around 10 hours give or take to assemble the whole 3D printer. I mean, I pretty much live streamed pretty much the whole process, 2 hours, and every single day I invested sometime in the morning, sometime in the evening, and I just progressively kept adding to it, kept building to assemble the printer. There were a few hiccups here and there. That's what took a little bit of time. For example, putting in the wrong screws, the wrong alignment, and those are the things that just happen if you're just assembling, whether you're assembling an IKEA furniture or you're assembling a 3D printer. It's just that there are more parts, so it can get a little tricky. Overall, I thought the experience was absolutely good. It was great actually. The pieces fit together well. There were a few sockets or where you had to put a nut in and you had to put a little bit more force than usual for it to go in, but it was all well explained in the handbooks. So the instruction manual is all I needed to basically assemble the whole printer. It's well written. I think everything is, at least for someone who's new to assembling 3D printer, I thought it was very well done. Now, why did I buy the MK3 and not any other manufacturer or not a different printer? I was actually planning to buy the MakerBot. So if you really look at it, I wanted to show you that in the beginning I was actually planning to go and buy the MakerBot 3D printer, and because I was planning on using this to download drones, build materials, build components for drones. And the Method X was something that I was actually looking for in the beginning, because I wanted to print ABS and I wanted to print materials with higher strength, carbon fiber filaments, and I didn't know whether Prusa could do it. But now that I think about it, knowing that half the materials in here is just made out of PETG and they're supporting a mechanical structure, like supporting like the stepper motor, they're supporting a frame which is not light. It has to have some strength. It can be breakable, but it also has enough strength to support a machine like this. Makes me wonder, or think that there are different materials that I don't necessarily need to print. ABS, PETG, PETG can very well handle some of this stuff. So I actually printed a small little this is the board that you normally see. So if I just zoom in a little bit, and I thought I printed it very well, and it's pretty strong. It's just like PLA, the material that comes with default, and it's sturdy, it's strong, which makes me again wonder, yeah, if I take a hammer, it's probably going to break, but in what circumstances am I going to, for a matter of fact, if I take a hammer and hammer anything is going to break. So that's not the way to test something of this sort. But from the most part, can my physical strength break something off? And just, it's strong enough. It's printed it so well. I'm really impressed. There was literally no hiccups in printing. The only issue that I had while doing the first printing was the leveling. So you need to make sure that the nozzle goes very well, is aligned perfectly onto the bed, because I had it a little higher and was not sticking onto the bed, so it was basically printing in midair. And I didn't know what was the reason. At least when I first got it working, I was like, wow, it's working. It got me excited, but I didn't know why it was not sticking. And then I need to do a little bit of calibration. And once I got the calibration right, I even printed a whistle. I don't know where I kept it. I think my cat took it and was playing with it. But it made these functional products. And I thought it printed it so well. I'm very impressed by the print quality. This is really well done. It's it's not the cheapest printer in town, but it's not the most expensive printer either. As I mentioned, the MakerBot, this particular printer is really expensive. That was my first choice, and from reviews I heard that it was not a reliable printer. It didn't have the reviews were not very, very good. And for me, reliability is a big thing. I don't want to be fixing and tuning a 3D printer. I'd rather have a printer that works right off the get-go and prints quality material, quality prints like this, which is something that I'm looking for. And also I bought the enclosure, which is in this box over here. This is the big box for the enclosure, and now I can even print ABS and have materials that need more heat. So it needs to be in an enclosure, so the heat is trapped and there's no wrapping, and the material can actually print. So I even bought the enclosure to print, ABS, and I realized like with this whole deal, and I'm paying in Canadian dollars, came to around $1,500. The enclosure is expensive. It's still cheaper than any of these products that are high-end, so-called, that seem to be what a lot of industries, a lot of people think, I won't say industries or people, but I'm just saying generally, even with all of those enclosure and printing such high quality product, printing a part with high quality, seems to me that it's a good cost balance compared to a printer that is way more expensive and is not as reliable. That's what I was looking for. Like for me, the reliability issues was one of the things that got me into thinking about the Prusa. I was never thinking of getting the Ender or the Creality. Anything below $500 was not my budget, because from reviews it really meant that you were spending more time tinkering and playing around with the product, with the printer, than actually printing. That was not what I was going for. I am not a researcher in 3D printing. Yes, it's fun to build things, but I'd rather build the drone and not the equipments that are building the drones. That's the way I was looking at it. So I wanted something that had a balance of not too expensive, high reliability, high quality, have a variety of materials, less proprietary in some sense of the word, and flexible. So I can use any spool that I want. So for example, if there's a spool over here. Let me just pull it out over here. It's all stuck. So this is in here. No. So this spool over here, which is basically, let me try to pull it out over here, is a PLA spool. I can replace this with any spool. I don't have to use any proprietary spool from Prusa. I can use any spool that I want, any filament, basically any material, and I'm good to go. Put it into the extruder. Maybe I have to change the extruder based on what I'm printing, depending on what type of filament. But those are things that I am flexible with, compared to buying, say, a printer that you only have to buy their products in order for it to work. All right, it's coffee time. So putting all those things together, and with the cost, I think it's a deal. It's a really good deal. I don't necessarily believe that it's the most like you need to go cheap. I think being flexible, you can save a little bit of money, and that's what I did. I saved a little bit of money to invest in a printer that had a balance of high quality and relatively cheap. Like it's relatively cheap compared to most of the 3D printers out there. Even like the other ones that were there, like the Ultimaker, they're all pretty expensive, and from what I've heard, like they're not necessarily reliable. The printer jams. I guess they're better quality right now. And there's one Ultimaker in my library, in the public library close by, where I generally have seen people print, and the quality was like, it was okay, but they had to like replace the printer like 2-3 times, and they bought the Ultimaker. I believe it was a 2 Plus, or the S3 if I'm not mistaken, and it kept like having issues that they kept upgrading it. Then they bought a newer one again. And it didn't give me a good view about the Ultimaker, in the sense it was a good, reliable printer, but it also had issues. And these are not cheap if you go, in this route. So if I get pricing, I'm not saying that you shouldn't be buying these printers. Don't get me wrong. I just feel like the cost, reliability, and putting all these things together, it felt like, the Prusa was the choice that seemed to win in many regards. That's the way I look at it. So let's look at the cost of this. Do they put the cost anymore? Get pricing. Okay, what's the Ultimaker S5? Now this may not be in compatible with over 200 materials. Use your parts. So if I go over here and put cost, so you're looking at a $7,000 US dollar product. Like, there's a difference between a $7,000 US dollar product and a $1,500 product, right? Like, you tend to believe that it should be like 7 times better, but it's not. Like, and that's where it comes to, like, I'm not comparing it with the Ender or the Creality. I'm actually comparing the Prusa with the high-end printers, and I realized like it's actually able to produce very high quality for its cost and compete with them, you know, pretty much at that level. Now, most likely these printers are expensive because you can do a lot more production grade stuff. I don't know how far that's true because I've seen people use the Prusa for even production. They have them in production farms printing materials for their products. So having said that, putting the cost balance, I just made it very clear that I wanted to make, but the Prusa just seemed to be the choice that I went for. That's the way I looked at it. Anyways, so having said that, what am I going to build using this printer? How does it help in building drones? And what's the purpose of using something of this sort? The way I want to basically start working with this is one of the first things that I want to build is where I put this over here. So this is something that I built in 3ds Max a while ago. Not in 3ds Max, in Solidworks a while ago. And this is a load test analysis. And this is generally, people would use aluminium for this stuff, and I want to see if I can use it, make a 3D printing model, print this in 3D print using a 3D printer, and see if I can create a load stand where you put the motor in here, and then these are load cells, and each time the pressure of the motor hits the thing, you record the amount of thrust. It's a thrust stand basically. How much of thrust the motor is generating, and then you change the propeller, you change the motor, you can play with the configuration, and this is your electronic speed controller. So as I'm building a lot of electronic speed controller, I wanted to basically create a thrust stand to test the thrust, and I thought that this particular is basically the model, and one of the things that I plan to do is basically print some of these parts. So if we go to the 3D view, and let's basically start to look at the yeah, this is not the one that I want. So this will be like the parts that I could basically print. So one of the things that SolidWorks allows us to do is, like, you can go to File, you can click Print 3D, and it does have a preset for the Prusa Research Original 3. You can put the bottom plane, so this would be the bottom plane, so it'll print in here. I'm still testing these things out, and you can save to file. So there's an STL version, and then there's a 3D manufacturing format. So I can click Save File, I can click Save As. It's the Mount 2. I've already basically created it. It's 43 KB. I'm just going to click Save. I guess replace it. It doesn't matter. Wait a minute. Where did I save it? Save File, Save As. I'm going to take this link and put this over here. I also just downloaded the Prusa Research Prusa Slicer. Let's see what we have here. Okay, this is the Prusa Slicer. And let me see if I can open a project or open a file. Yeah, here we go. So 3MF, I click open, and yeah, perfect. So I'll try to basically, I want this to be the other way around. So this is the first time I'm playing with this, so let's see if I can rotate it. I don't think you want to print it this way. This could sag, and we don't want that. Rotate the, okay, so this is the, I want to rotate it with the, is this the x-axis? What is the red one? This is red, so this might be xy. So I'll rotate it y, I guess, I believe. So rotate y by 180. Oh, so not y. Yeah, perfect. There we go. I think that's what we want. Yeah. Yeah, that's perfect. And then printer settings, layer height, layer this, solid layer. Filament settings is going to be color, dimension, nozzle, other layer, filament over. Printer settings, extruder one, dependencies, general, platter. I don't know. Looks good to me. And what do we do to print? So we click export. Printer settings, default, simple, advanced, export. Okay, this is simple. How do we click export? Export G-code to SD card flash drive. Okay, so let's try doing this. Do I have a... So I'm gonna put my SD card in. And let's export. We don't need any of this, I don't think so. And in here, I'm going to click File, Export, G-code to SD card flash drive. This is going to be in the iDrive, USB iDrive, and just click Save. Perfect. Eject drive. Simple as that. So you can basically work on SolidWorks, bring it to this Prusa slicer. It'll generate the G code, and I do believe. Oh, this is me being really stupid. Okay, this is a USB pen drive, and yeah, we don't have a pen drive. It needs to be an SD card. So I believe I already have an SD card, so I'm just going to click File, Export, Export G card to SD card. I believe I have an SD card here. Yeah, the SDH. Let's save it here. Okay, and now let's. Which can now be safely removed. Perfect. Now let's see if I put it into the Prusa. So here in the Prusa, do I have it on? Should have it on. So this is the Prusa. Let me see if I can zoom this a little bit in here. Maybe. Nope, I can't get the camera angle right. Yeah, it's difficult. So I'll try to basically, yeah, put the. So here it is. I tried to adjust the camera angle, but not perfect. So what we can do is I can remove the card. This is what they give you. So you can, I just remove this, and I'll just basically put the one that I just printed. Print from SD card. Static test motor. And we'll see if it prints it. So the goal over here is to print this, and I want to see how it prints. So one of the things it first will do is it'll create this line over here. Or first it'll do the calibration to make sure that it's got is printing within the area of the print bed. It does this for every single print. And now it's heating the bed, so it'll wait till the bed gets heated. I won't be positioning this over here. I will be positioning this printer more like in the corner over here. But I just want to show you how easy it is. Like I can print it. The whole idea of me working with different softwares. I think it can even directly print the 3DM file. So I could directly even go from SolidWorks, generate that file, and put it into the SD card, and it would still work. From my understanding. The only issue over here was that it imported it kind of like the other way around, so I had to just make sure it worked in the right orientation. That's really it. And yeah, so let's go over here, and it's starting to print. And let me have a look at what we're planning to print over here. And So from what I'm observing is that it's not. I might have to. Yeah, I gotta cancel this. So I believe you can just cancel and cancel it. So it's creating some issues over here, and one of the issues is yeah, I can show you what the issue is. So I'm just gonna turn this off. And it's most likely because I didn't clean the bed. It started to basically so let me go over here and show you what I mean. So it started to like create these things over here. So it's got to do with the settings. So let me see if I can play around with the settings and see what I can adjust in the Prusa slicer. So I wonder if I can go to the filament settings, printer settings. So one of the things that I've observed in here is that this is slightly thick. Yeah, it depends on how you're printing this. So I want to make sure, like, can it like let me see over here. So supports none, Prusa, scale, rotate, place on face, cut. I want to know if I can create those lines and filament settings, printer settings. Here's the infill, fill density, expression default value is fill density. I don't know, but let's like 80%. Fill pattern, star, maybe, yeah, star seems okay. Skin and brim. It did create the outer brim. Support material. So one thing I want to do is like Prusa, how do I create a line? Prusa, before printing, create line. I don't know. How do I start my prints with a line? Yeah. All my prints that are part of the printer, such as, and I'm wondering how to incorporate into my own prints. Sounds like the prime line used to get filaments flowing evenly. The startup G code in your slicer will be included. If you're using Prusa slicer, anything yes, slice and send to the printer should start with the same routine. Insert a picture. Do you have a Prusa printer? The start G code is autumn. Okay, so it says that it should automatically be there. So I'm just going to try it again and see. The printer is filament. Okay, so printer settings. Filament settings, printer settings, plater. You know what? Let me just click and export and click export the G code again. And see what's the issue. Okay. Export, you go to flash drive. I'm gonna put this again, save, replace it. And now what I'm gonna do is again try to print and see what the issue is. Yeah, it might be. yeah, I mean, so it's doing the calibration again. Some problem encountered to leveling enforced. Z leveling and enforced. Okay, calibrating the Z axis. Well, because I manually moved it, so yeah, makes sense. I know we shouldn't be doing this, but one of the things I think I should be doing is putting a stick in here, the glue stick. Shouldn't be doing this, but oh well. So it should stick to the board. So now it's heating the board, the bed. Hopefully the glue stick allows it to stick. Yeah, I didn't draw the line. Oh well. I think it's printing a lot better right now. I think it's printing much better right now. So maybe if I can just slightly, yeah, it's completely. I don't have a camera angle right now for it. Maybe when I put it in the right location, I'll probably put a camera angle in here to print it. I'm also live streaming, so if I wasn't, then I would put a camera right in front of it. But so far, it's looking good. Yeah, it's just a matter of the filament was not heated well properly, and I didn't put the glue stick for it to stick, so it came off. And now I think it's looking good. So once it's done, I'll show you how it looks, and if I can start printing things like this using a 3D printer, it would really be super awesome. Like super duper awesome. That's really it. Alright, that's it from me. And until next time, thank you.